All right, ready for Monday's homework. CPM, back in the book, starting chapter 3. You guys are cruising. Pages 103 to 105. A lot of problems on this one, 312 to 321. But you got this. I'm going to help, right? All right. Again, first thing you do, all right, get that paper out. Get those easy 3 points. Get in the habit. The very first thing you do is get that paper out and get the name happening, right? Right, Chris Mullin? Chris Mullin? Who's that? Part of the famous Run TMC. Tim, Chris, and Mitch. Tim, Mitch, and Chris. Tim Hardaway, Chris Mullin, and Mitch Richmond. Right? Famous Warriors in the 90s. Real fun team to watch. Chris Mullin, good guy. All right, so you got that. Get the name. Then you got the date. You may notice in the warm-up that I put the wrong date down. It's the 16th, isn't it? All right. Put your teacher's name and the period, right? And then if it's out of the book, put the problem numbers, please. All right, start doing that. 312. It's just a few, I'd write them out, but I'm going to write the word through here. This is the through that is going through, not I threw a baseball, right? That's a THREW. And it's all the way through 321. Okay. And again, boom, 30, 45 seconds, whatever it took with me talking about Chris Mullin, Run TMC. Doesn't take long to get those 3 points. All right, let's do it. All right, so we got here the very first problem. Let's flip it. Let's flip it. Move the computer over a little bit. Okay. All right. So the very first problem, we talked about that magic 1, and we worked on that last week, right? Want to get you a head start on that. So all you have to do is complete. So do me a favor, never give me an answer sheet. What do I mean by that? I don't want a list of answers. I want to see the problems that you guys are working on, and I want to see how you got the answers that you got. So write the problem and the answer, okay? Doesn't take that long to copy most of these down. Now, if it's a long word problem in a whole paragraph, I don't expect you to copy down all the words, but I do expect you to show me the math that you end up doing. Okay? Show me the math that you end up doing. And I'll show you what that means, because the next problem, whoops, it's times 4, whoops. So let's erase that. Erase that with a pen. Ha! All right, and see, 9/20 times, Mr. Daniel is not very good at talking about one thing and doing another, right? Notice that when I do my warm-ups. All right, so how does this work? Well, 3 times what is 18? 3 times what is 18? If you knew it was 6, good job. And if that's a 6 has to go on top. And then you go 5 times 6 for that answer. Okay? 20 times what is 100? Well, 20 times 5. And there's a 5 on the bottom, and this equals 1. A 5 has to be on top, so you go 9 times 5 there. Now, this is backwards. Don't get too confused. 4 times what is 28? 7. And if the 7's on top, what has to be on the bottom if this is 1? Okay, and then you have to do what times 7 equals 63. So we're going backwards there. Don't freak out. Okay? All right, 313. I think you can do those. Give you enough of a boost over that fence. Rachel says when she ran 115 yards, she went further than Beth, who, you see, my parents are from the South, so I said further instead of farther. She went farther than Beth, who only ran 327 feet. Is Rachel correct? Explain how you know. Well, I'm talking about, they give you that hint there. 1 yard equals 3 feet. Let's write that down. Okay, and so we want to figure out 327 feet equals how many yards? Or we can say 115 yards equals how many feet? Okay, either way, right? So you can multiply this times every yard is 3 feet and figure out how many feet and compare that to this. Or you can say 327 and divide it by 3, right? Remember, the first number goes inside the box. Divide and see how many yards 327 feet is and compare it to 115. And then you could decide who was right? Remember, Rachel did the 115, Beth did the 327 feet. So multiply, and I challenge you to divide too, to do them both. And just do that little bit extra. It's good practice. And again, now we have these graphs, right, for 314. 314 is pie time. Pie time. What is he talking about? Yeah, watch my videos on Friday. Lorenzo loves them. They're fun. They're inspiring. Sometimes you might even shed a tear. The Tigers and Panthers. Or the Jaguars. All right, 2 basketball teams, and here is the height of the players. They have these histograms, right? And I'm looking at the height of the players here, 6'3", 6'6". That's how many people. One person is between 6'3" and 6'6". Nobody is in between 6'6" and 6'9" on the Tigers. Looks like there's 2 people between 6'9". Oh, that's right. That's 69 inches and 72 inches. These guys aren't that tall. I'm 80 inches. So I'm going to be in this bar, right? If I was on the Tigers, or I'm going to be in this bar if I'm on the Panthers. So 72 inches to 75. There's 5 kids on the team, or 5 players on the team that are that tall. And there are 3 people, 75 to 78. So the question first is, and I would normally love it if you would do this graph and copy that graph down. But I don't want this video to be too long, so I challenge you to do that. Which team has the taller players? Which team has the shorter players? Explain your thinking. I got to tell you, okay, that this is one of those questions the answers will vary. You know, why do you think this team's taller and this team's taller? This team looks like it has a lot of players that are taller than 75 inches, right? 3 and 2. 5 players are taller than 75. But look how tall this graph is. Is that how tall people are? Think about that. All right. So different people have different answers. Same thing. Which team has heights that vary more? That means there's a lot of differences. Explain your thinking. And again, you might have different answers. And I kind of want to know what you think. I don't want to tell you what I think. Okay. This is one of those, you interpret it. You give me your guess. You can't really get it wrong unless you're lazy and you don't do it. Okay. Which team has more players that are about the same height? Okay. So you're going to answer those 3 without my help. I'm just telling you what the graph means. 63 inches, 66 inches. And again, Mr. Daniel is 80 inches. I'm way off the charts over here on the end. 315. Okay. Find the measure indicated in each question below. So you want to find the perimeter of that triangle, 3-15. And that triangle, I can draw it. It doesn't have to be perfect. Whoops. I should have it. Let's just redo it again. Mr. Daniel talks while he does stuff. 7.25 centimeters, 7.2 centimeters, and 8 centimeters. The perimeter is, add up those distances. When you add decimals, make sure you stack them and line up the decimal. Where's the decimal in the 8? Remember, if there is no decimal, it goes after the number. Okay. And line up the decimal straight up right now. These don't come out to the same spot. So I always recommend, if they don't come out to the same spot, add zeros until they do. Okay, you're a lot less likely unlikely to get it wrong, likely to get it right. Okay, the decimal comes straight down. So you add those and get the perimeter. Make sure your units are in centimeters. Okay, now that was A. Sorry for the mess here. B, we have to find the area of the rectangle. The area of that rectangle, and it looks like it's 1, 2, 3, 4, 5, 6, 7. So I'm going to draw it like this and use these lines. 3, 4, 5, 6, 7. And it's 4 wide. 4 is easy because you just go in half twice, right? All right, we're going to call these squares. So I got 7 rows of 4 squares. What's the area in square units? So you can count the squares, or if you know the secret shortcut, use the shortcut. Okay, now C, find the area and perimeter of that rectangle, and that's a long skinny one, and it doesn't have the squares inside, so I can just label it 2 inches by 8 inches. And remember, perimeter goes all the way around. It's not 2 plus 8. That got you halfway. Go all the way around. So I'm going to put perimeter there, and that is going to be inches. And area is always going to be square units. So I'm going to say square inches, and that's when you multiply. Okay, so you know how to do that. All right, let's do 317 or get you started on that. Distributive property. Okay, now there's 2 ways to doing this. There's the real detailed way. But basically what you're doing, you have 12 parentheses 309. What does that mean? That means 12 times 309. Now, one way of thinking of distributive property is to use the generic rectangle. Okay, now if I had 12 times 309, you would say this is 300, this is 9, this is 10 and 2. And you'd say 10 times 300 is 3,000, 10 times 9, 2 times 300, and 2 times 9. And these 4 numbers, what you're going to write for the distributive property is those 4 problems. Okay, so what did you do? You did 10 times 300, and you're adding that to 10 times 9, and you're adding that to 2 times 300 plus 2 times 9. That's the distributive property. You figure out that total and give me the answer. And then box this. Try to bring it down and write it neater than I did. Now B, you have 8 times 100 plus 10 plus 8. Now, you can write this out with a generic rectangle and do 100, 10, and 8. But you can also just know anything outside is going to get multiplied by each thing inside. 8 times 10, or 100, plus 8 times 10, plus 8 times 8. I wrote 8. I think that's supposed to be, no, it is 8. Okay. Okay, and then you can put these in parentheses if you want. All right, so that is the distributive property. You distribute the thing outside to each thing inside. I always think it was like you're distributing, it's like you're dealing cards, right? If you're playing Uno and one person gets 8 cards to start the game, well, everybody should get 8 cards, right? Everybody gets the same amount. All right, all right. 5 notebooks cost $5.25. How much would 3 cost? Well, wouldn't it be nice to know how much 1 costs, right? Well, how do you find out how much 1 costs? Well, if 5 costs this, then this divided by that. So you're going to see how many times 5 goes into 5.25. And when you're dividing the decimals inside the box, you just bring it up. Outside the box is tricky. I'll have to show you that later. Now that'll get you 1. Okay, take that answer and do times 3. And that will be your final answer. Okay, you know how to do that now? All right, 319. Jing Ya takes the bus across town each morning, and this is how long it took each day. Okay, 15, 10, 11, 13, 11, right? And it's on A, it says, what if you had to use one number, what would you use? Okay. I'm going to let you choose that. Okay. I'm going to let you choose that. And hopefully, if you choose to do a special number, you know how to get that special number. And then on B, it says if he does not want to be late, he has to be at school by 8. What's the latest he should get on the bus? And then again, right, that's kind of magic. Oh, do you walk out there and the bus is waiting for you? No, you're going to pretend like it does so you can do the math problem. Okay? All right, 320. Dot and patterns. All right, 1. We got 1, 2, 3, 4. Figure 2, 1, 2, 3, 4, and then another row on top, 5, 6, right? So 4 dots, 6 dots. Figure 3, 1, 2, 3, 4, 5, 6, and another 2, 8 dots. All right. Oh, sorry. Uh-oh, I just gave you the answer, didn't I? 4 has 5 rows of 2. 2, 3, 4, 5, and they want to know what 5 does. So 1 has 2 rows of 2, 2 has 3 rows of 2, 3 has 4 rows of 2. All right, so you see if you can figure out these answers on this one. Okay, now bonus if you make an input-output on that one. Okay, remember the input-output. What do I mean by that? If you do the in, out, and this is the figure number, and this is the number of dots. So figure 1 had 4, figure 2 had 6, figure 3 had 8, 4 had 10, 5 you're going to figure out. How many would X have, right? That's kind of cool. So you don't have to do the 50th, and you don't have to do 38 working backwards if you figure that out. That's like having the draw 4 wild card. All right, last one, 321. Stacy exercises 3 days a week by walking around the soccer field, and it's 80 yards wide and 115 yards long. Draw a diagram of the field. You don't have to be an artist to draw a soccer field. You know it's a rectangle. 80 yards, 115 yards, and she's going around it, so that's called the perimeter. Okay, and I think knowing that, you can do A, B, and C. Even C, yeah, do that challenge. All right, answers coming your way tomorrow. Good luck. If you start this early and you get stuck, you can always see your teacher for an afternoon Zoom and get help, right? All right. Good luck, everybody.